An Arctic nor'easter snowstorm is brewing for New Jersey this weekend. All right, so here we go again, right? This is 850 millibar wind streamlines from the Null School Earth map. And just want to illustrate that it's very cold. You can see the tropospheric polar vortex is spinning right here. The cold air is just funneling down. And, if we go look at the Rutgers, New Jersey temperature, you're already at -1 up here in Sussex County, single digits. Much of Jersey is in the teens, and you're just slowly, leveling down. And it's going to be this way through this weekend. I think maybe Friday is going to be the coldest point, but tomorrow night will be colder than tonight, and just colder and colder and colder. You'll get evaporational cooling with light winds, and it's just a nasty week of cold straight through Friday into Saturday. And then we get to our period of interest, which is late Saturday night through probably Sunday. Whether or not it bleeds into early Monday a.m. or it wraps up Sunday night, yet to be seen. Still a little bit of difference in timing there. But I want to talk a little bit about how models work. It's very important for tonight's discussion. So you have weather sensors, all over the world, sensors on the ground. Weather balloons are sent up into the atmosphere to collect information. You have buoys, marine buoys out in the ocean that are collecting information. And, all this information is pulled together. It's mostly temperature, humidity, and basic, data that, advanced calculus is then used to come up with more advanced parameters. But more or less, these weather stations pull in all this data and feeds it into an algorithm. And the algorithm looks at the last 30 years of climatological history and compares how the atmosphere looks right now to times in that 30-year period where it's been the same. And then it makes a prediction. It makes a numerical analysis of what's going to happen based on what we've seen in that last 30-year period. So, recent funding cuts has meant less balloons, less maintenance. So it's definitely made forecasters' jobs harder. But one thing we saw last week was that they actually deployed dropsondes into some of the energy upstream, and that made a huge difference. I believe it was last Tuesday night where they did that. And up until that point, this past weekend storm was looking like it was going to miss to the south and be suppressed to the south. But when the flight data went in, everything came north. It injected it with fresh data. The algorithm recognized it and saw that this was going to be more of a New Jersey, New York State, New England, southern New England kind of storm rather than a Virginia, North Carolina storm. So with that said, these are the dropsondes. These are the sensors. They drop out of an airplane, and it collects data as it drops, and eventually, hits the ocean. And it has collected, temperature, humidity, pressure, whatever on its way down. And then that gets fed into the algorithm. It enhances the algorithm because it's simply more data. It's more accurate data. So a little bit of dropsonde data made it into the 18Z suite that ran earlier this evening. However, there's going to be more dropsonde data in tonight's 0Z suite. Now, I know this is a late video. I wanted to stay up for the GFS just to confirm my suspicion that this flight data would mean a little bit more of a northwest tick to the storm. And sure enough, that's the case. But let's dive into the upper level players of this system. Okay, so I'll go back out to the US view so I can show you the main players. So here you have this trough right here, right? And it's a weird looking trough, right? This is how the big ones start. It's very flat and extremely positively tilted. And this is that cyclonic vorticity I talked about the other night. Air that's spinning is represented by bright reds and greens and yellows. Air that's straight is just white. So, as we go through here, Friday, Saturday, notice that the axis of this trough is spinning, right? It's spinning counterclockwise. And you get to about here, and I'll zoom back in to East Coast view here. It's very important to look at these streamlines at 500 millibars, which is like 18,000 feet up, about, give or take, depending on what your heights are. But these streamlines actually steer the low pressure, right? So if this was a vacuum and the air was always like this, a low would come around through this streamline and go just like this. If there was a low right here, it would actually go like this, which we'll talk about in a little bit. But then we have that concept of positive vorticity advection that I talked about, where you have air moving through, it's spinning, and then it comes into this area where the air is moving straight. So as spinning air transitions to straight moving air, it's just like that figure skater spinning really fast, and then they spread out their arms, right? And as they spread out their arms, just like the atmosphere spreads out its air, it drops pressure. So here is the greatest area, right about here, where the air is changing from spinning to straight. So, I don't even have to look at a surface map to know that the low is going to be right about there. Let's go over hour 96. Yeah, right there, right? So that's what kind of governs your surface low formation from the upper levels. And this is why looking at this is very important. Now, you see this blue line here? This is the 540 line. And I'm using that as just visual reference to see when the trough goes negative. Right now it's still positive. However, there it's negative. If I step up to a North American view, you'll see this much better. So see right here, the trough axis is positive. I'll draw this here. See, it's positive right there. But if we rock a little bit forward in time and get to about here, well, now you have a negative axis. I'll draw that. Now the axis is more like that, right? So this is a negative tilted trough. This is a positive tilted trough. If you want a big coastal nor'easter snowstorm, you want a negative tilted trough, which is what ultimately brings the storm in to the coast in what's called a retrograde, or even a stall, or even a retrograde. And look, I don't use the term nor'easter lightly. I can't stand when people call a regular progressive coastal low a nor'easter, something that just comes along and sails out. To achieve nor'easter status, you have to have a stall or a retrograde, something that pins northeast winds into the coast for more than just a 6 to 12 hour period. Let's go back down to the east view, though. So again, you see this. Actually, I'm going to go up to the US view to show another player. So that's the trough and how it turns, negative, positive. The other player on this field is right here. Now, this is the southern stream energy. Now, this energy needs to fold in. It needs to wrap in and phase for this to happen. If this energy gets left behind, then it just pushes the storm south and east out to sea. But you ultimately want it to just wrap in and feed right into there. And that's why today, I did this symbol, because it looks just like that, in my opinion. I don't know. I think it's funny. I'm mostly Italian, so I think it's even funnier. But so that's the upper level players, right? The trough, the southern stream of energy phasing in, and then the steering currents of how it influences that low. And it's very important, because once we get off here, go back down. Once we get here, these steering currents are actually, if a low was right here, it would actually take it down here. And that's called a retrograde. Instead of the low just progressively going out to sea like a regular coastal low, now you have a low that would want to come in towards the coast. It at least stalls it, but it possibly retrogrades it inwards. And that's where you get the historic Miller A nor'easter snowstorms that have hit Jersey in the past. So, surface implications. Again, I wanted to wait until the GFS ran tonight, and I had a hunch that everything's going to come northwest. It started to come northwest as that initial flight data made it into the 18Z run, but here we are at 0Z, and the GFS has come even further northwest. So see that? I mean, this is nailing I-95 and southeast. It's a little bit of snow for northwest Jersey. I don't think we're done with the trend here, but I can tell you 965 is a very powerful low. That would be pretty. It would be a lot of storm surge. That would be a lot of wind-driven ocean, pushing into the land. But what it would also mean is a much larger precipitation shield out here, which we'll talk about in a second. But yes, the GFS has come northwest. The European model. This is today at 12Z. This is the 12Z run earlier today, like 1 p.m. It was very far out here. Once the flight data made it in, though, if I go to 18Z, look at that. 12Z, 18Z. It's coming west, folks. It's coming west. And another piece of data that's actually most interesting to me is the ensemble members. Specifically the 18Z ensemble. So this is 12Z. Now, ensembles are different. When we look at models, you have the operational model, which is a single run, right? Ensembles are multiple runs. I think there's like 51 different cores in the European computer. So what it does is it starts with 51 slightly different conditions and runs them all at the same time, and then generates a mean average of what the future output is. It's a way to kind of weed out outliers and see what the average of all those different starting conditions are. And from this range, which is where we are now, about 4 days away, 4.5 days away, whatever, maybe even less now. Ensembles are a better piece of data to use, in my opinion. But this was 12Z today, tightly clustered on the east side of this area, but too far away. So now let's go to the 18Z that ran later tonight. Ready for this jump? Closer to the coast. And because this is closer to the coast, the 0Z Euro that's going to run about 1 a.m. overnight tonight is probably going to come west too. So I think a lot of forecasters who jumped ship today and just set out to sea, it's going to be a miss. I think they're going to be singing a different tune tomorrow, because tomorrow will be 3 days away, and that's where we start to really open our eyes and get ready to call this thing. So the other thing I want to talk about is precipitation extent. So let's go back to the GFS. Oh, and look, you see where this low is right here? You have the upper level low. Look at the low track. It retrogrades in. It retrogrades in like that. And that is because it is spinning around the upper low, those steering currents. That's where it wants to take the low. So as this trough of steering currents moves through, these streamlines steers the low. And that's why the low comes up and does this, just as you see here in the surface output. But let's talk about this. You see this location right here, this 975 off Outer Banks, yet the precipitation shield's kind of weak. Sure, there's high pressure. It's not really crazy high pressure, but it's there. There's going to be a tight cutoff here probably because you have cold, dry air feeding in. But I think this precipitation shield is underestimated. And you might hear forecasters say that 9 times out of 10 storms trend to the northwest. That's true sometimes. But other times, the precipitation shield was just underestimated. If we go back to January 2016, that was a very historic snowstorm. Okay, I don't know if you remember the cruise ship story where for a week long, everybody was screaming, coastal storm. A cruise ship went through it, and some of the video that came out of there was just very disturbing, actually. But my point was the low was down here for this storm in 2016. It was off the Outer Banks, and it didn't even pass over the benchmark. It was actually southeast of the benchmark, very slow moving low that stalled and went out this way. And the precipitation shield reached all the way back into State College, PA, almost to the Catskills. The heaviest band of snow was through New Jersey, not just southeast Jersey. So I think we might be dealing with a little bit of that as we get closer. That's why the mesoscale models in the short range are a little bit better at handling precipitation shields than the global operational models from this range, like the GFS Euro and Canadian. So, once we get to like Friday, Saturday, and we're looking at things like the NAM and the RGEM, long range of the HER, I think they'll do a better job with the precipitation shield, because I don't think that this precipitation shield is doing this 974, 966 load justice. Another thing is low pressure tends to trend downwards, 966, maybe it's like a 975 to a 980 by the time we get there. Still a very powerful storm. And that's the last thing I want to talk about, is coastal flooding. So, as much as everyone's excited about an Arctic nor'easter bringing a lot of snow to New Jersey, because, even in this GFS case, if I zoom, let me go to snowfall output, right? That's a lot of snow there. Let me zoom in all the way into New Jersey so that you can see how much snow this really means at this point, even with a graze. Yeah, that's like 10 to 20 southeast of I-95. And here's that sharp cutoff. I don't think it's going to be that much of a cutoff, and I think there's room for this all to move northwest still. But ladies and gentlemen, this is a rough nor'easter snowstorm hit for southeast Jersey, even in its current state. And again, we're going to watch the Euro tonight to come in, because I do think that's going to tick further northwest. But back to the coastal flooding. You are going to have a very powerful low in about this position, and you're going to have winds coming off the ocean, right? Another thing that's not so fortunate here is that we have a full moon on Sunday. So when I look at nor'easters to gauge how bad the flooding is going to be, I look at three things. One, the amount of rainfall usually in a nor'easter, because that rain needs somewhere to drain, right? Two is the storm surge potential, right? The wind-driven top layer of the ocean that's pushed into the inlets and against the beaches. And three, what phase of the moon? Because when the moon is in a full moon or a new moon phase, you have higher astronomical tides. So when you combine the higher astronomical tide with the storm surge and with rain draining into it, that's the trifecta of, holy crap, flooding. Now, the one advantage we have is we won't have rainfall, because this is an Arctic nor'easter. This will not be rain. I'd be very surprised if this trends inland to the point where rain makes it into New Jersey, given the air mass that we're in right now and we're going to be in until, Sunday. It's not like this past weekend. So snow doesn't drain into the back bays, estuaries, and oceans, right? So we at least won't have that element, but we will have the wind-driven storm surge. We will have the full moon. So if this powerful low gets right into this position, you can expect, probably at least minor to moderate coastal flooding for east central Jersey, southeast Jersey, right off the ocean-facing coasts and the inlets and bays and everything. Hopefully that doesn't push into the heavy flooding or whatever. Hopefully it just stays in like the minor to moderate. So coastal flooding is something I'm going to be watching in addition to whether or not we're getting snowfall. And then there's the wind element. It's going to be very windy around a sub 980 low. So if we get pinned at 35 mile an hour winds for 3 hours or more, and visibility is reduced to a quarter mile or more, we meet blizzard criteria. So you potentially have an Arctic nor'easter blizzard snowstorm staring us in the face this Saturday night through most of Sunday. I will continue the schedule as I laid it out yesterday. A daily article at this point pretty much that gets into Kaboom Club by 1 or 2 p.m., publicly releases by 5 p.m., and then a YouTube video like this at night. Seems to be a nice little pattern. I love doing these YouTube videos so I can visually show you things, convey a lot of points that are hard to convey in written format. However, I know a lot of you like the written format, so I'm trying to include text summaries with these videos in the description so everybody's happy. But otherwise, yeah, we got a long couple nights going here, but it's coming west. So everybody have a great rest of your Tuesday night, and please be safe.